I can't read it.
Okay, you graphed these. I think a lot of you, maybe even today, when you walked in, you thought, I think we just talked about it last year, maybe you even talked about it yesterday. I think I just proved this yesterday, didn't I? That these are the same. So then you were in for a little bit of a surprise then, maybe, when you actually did what I asked. Am I right? Bianca, would you speak to the question here? What conclusions did you draw? How did the graphs compare? Did you guys talk about it back there? Okay, so they do agree for positive values, but you added that like caveat. So do you want to say something more about that too? Where do they? Okay, that's true. Yeah, every log graph will, I guess. Yeah. Where do they disagree? I guess I could ask. Or what's the bigger story too? Do you want to share?
For like the first function y equals log x squared allows for negatives in the domain, since like now that you have x squared, it's guaranteed that's going to be positive no matter what, so there's no reason to restrict the negatives.
Yeah. I mean, there is a larger domain for the first one. What is the domain for the first one? Someone else? Let's figure it out. But what is it? Yeah, all real numbers. Is that right? Still not zero though. Yeah, all reals except zero. It's kind of a punctured domain, right? We have all reals except zero. Good, and the second one is just positive numbers, like Bianca said. Yeah. Good. So I just wanted to qualify your proof yesterday. I think it's important in mathematics to prove things. Obviously, you know that I'm big on that. But it's also important to understand what you proved, what its scope and limitations are, right? So the thing you proved yesterday, I don't know if you kind of caught this nuance. That's true. The power rule is true for positive numbers. Yeah? All right, so just keep in mind that these if x is negative 10, then these are not equal, actually, right? So keep that in mind. By the way, can I was trying to I was thinking last night I was laying awake in bed. I was trying to think what are logs. I was really trying to figure out what they were, and I just couldn't fill in the blank. Well, logs are what? Wait, I guess we'll never know. I guess we'll never know. Okay. I know. I just wish I knew the answer to that. No one knows, I guess. You know, we'll never know. Yeah. Today we'd like to do some solving equations. Yesterday our objective was to, well, first of all, remind you of every property that you've ever known, or maybe some new ones if they were new to you, I don't know. To justify and remind you of every property that we know about logs and exponents. So that's hopefully what we accomplished. Along with asking you to simplify expressions. Today's objective is that we might be able to be faced with some equations that involve logs or exponents and solve them. So we'll have some interesting discussions today. We're not introducing any new properties. We're just going to see how they apply in this new context of solving equations. Let's start with an equation, this one here, that could have appeared in your summer packet. Let's just remind ourselves of how to deal with this situation where we have, like, you know, an exponential equation of some kind. Okay? So go ahead and do that, take a minute. And we'll also talk about why this up here matters. I have this like thing up at the top. Why do I have that there? I don't know. We'll solve this and then we'll talk about it. I'm pretty confident that you all solve it with great success. But then I want to reflect on like why it is that you can do what you just did once you actually solve it. Yeah, so we're free.
0 to the power of 0 to the power of anything 0 is there. I know 1 is. Sorry, I was talking
Let's equal 6. 0 to the power of 0.
You get x equals 6? All right. No? What'd you get?
Oh, that makes sense.
All right. Where is? How about we get? Yeah.
Oh, you want me to actually tell you?
Yeah. Show us the work.
Which board? This board or that board?
This board. How about?
Okay.
So as he's doing this, the first move he made, the first move you made probably was to divide by 20. Am I right, Jeffrey? Mm-hmm. Yeah, is that what he's doing? Okay, good. All right. So I think as I remember back to Algebra 1, I think, okay, I learned in Algebra 1 that I can divide both sides by a non-zero number of an equation. And that preserves the equalities. In fact, the entire solution set is still the same as it was before. Right? Any solution to one equation is a solution to the other. Cool. I also learned that I can subtract a number on both sides, and that the solution set still stays exactly the same. And I learned some other things too, right, that I could do to both sides of an equation. But one thing that maybe kind of when you first did this kind of algebra here, when you first did this move right here, that might have gotten a little bit skated, kind of pushed under the carpet here, is the fact that, like, is this something we can do to both sides of the equation? Like, remove the base, the common base. Is that like a thing we're allowed to do? So, I understand. I think I can divide both sides of by 20. And go back to, like, the balance that you used in pre-algebra, okay, does this keep the equation balanced? Whatever helpful analogy you have, is this like something we're allowed to do is the question. And this up here says that, yes, it is, apparently, but we should, like, stop to think about why this is true. This is saying, this first line up top is saying that if you have b to the u equals b to the v, which is the situation we're in, then it must be true that u equals v. And by the way, this is if and only if. If u equals v, then it also follows that b to the u equals b to the v, right? So either one implies the other. Perfect. Now I want you to stop and appreciate the fact that that's true, actually, because that's not necessarily true for every function that you meet. For example, if you have u squared equals v squared, does it follow necessarily that u equals v? No, it doesn't. So I want to make sure you appreciate the fact that, like, this is not always a thing that you can do. Like, there are certain things in algebra that we can do on both sides, and the solution set still remains exactly the same. And there are other things that we do that it seems to change the solution set in some way. By the way, what's the counterexample to this over here on the side here? Yeah, like -5 and 5. -5 squared equals 5 squared, but -5 is not equal to 5. So if this is not, certainly this implication works, but the other way doesn't work, right? If you try to do the downward implication here, that's not true. Yeah. Good. So what is a property of a function that we might be looking for? If we want to apply some function to both sides, like the divide by 20 function, we want to do that function to both sides of an equation. That's okay to do, isn't it? What's a desirable property that we might want to seek in a function if we're going to do that function to both sides of an equation? Oh, maybe it's up here. Oh, yeah. Maybe we'd like to have it be a one-to-one function. So why does this one fail? Well, the squaring function is not one-to-one, right? It doesn't have a one-to-one correspondence between inputs and outputs, right? So that's like a big idea that we couldn't have that conversation with you in Algebra 1. But both exponents have that property, and also logs have that property, that they're a one-to-one function, right? They're inverses, of course, so if one is one-to-one, then the other is too. So when we get to some equations later today, we'll also be making this inference as well, right? You'll see an equation of this form, and you'll make that conclusion. So just keep that in mind. And the answer is, of course, 6. Again, like I said, this should have been something you would have been comfortable doing in the summer packet. But maybe you haven't had this conversation about this, right? I don't know if you've thought about this property, the one-to-one property, and about the bigger conversation about solving equations in general. Okay, well let's just jump into one that I think we're gonna struggle a little bit more with. Okay, just because I'm like a very generous person, I'm gonna do the first step for you. Yeah. Okay. Now you. Yeah, you're welcome. Okay. So then see if you can even think of a good first step on this. I don't know. I need some insight. Talk with your group. Figure out. I just need even. I'm like already stuck. I already need like a good first step. Well, what do I even do? Oh, okay. The second step. I mean, I'm struggling with the second step. Is what I meant to say. Any insights? Oh, I have a sketch. We're you know, we were just talking about logs actually, solving some log and exponential equations and stuff.
Is there anybody in here that remembers logs from
Wait,
last year?
do you do logs in your class too?
I do. There are logs. I do teach logs in my class last year. Did anyone here have a second semester?
Did anyone have a sketch last year?
Couple of you.
So
Yeah.
some of you might have had this sketch. Others of you might be like confused why she's here right now. So she like blocks like what's the right analogy?
She's attracted like a moth to a flame.
Oh, thank you. I was thinking of something else. When she vlogs, she just
I can't
she's
help
walking
it.
by. She can't resist.
I can't.
So maybe you don't know Miss Sketch real well, but she does this thing
I do
apparently.
this thing
I
with
wasn't there.
logs.
I wasn't there.
No,
for
he
it.
wasn't there. He
So
wasn't there. And I tried to convince him that, that he should also learn from me. After all, I am the wise, sage, old, new, right? Should learn, right? From the master,
so, but
right?
how does it work though for those who are in Miss Sketch's class? What does she do?
What are
What's
logs?
the big deal?
Oh, logs
She
are
does a
handstands.
I
Oh.
was actually quizzing them earlier before, and they couldn't even fill in this blank. They didn't know.
What? Do not crush my spirit.
Oh, that might be why. They might have known actually.
Oh, they might have known. What are logs?
What are logs? Oh, they're
Exponents. And we remember that logs are exponents because I do a handstand while you yell it. So all of you that don't know me need to also participate. Nice hat. Need to also participate. And when I am on, if I'm gonna do a handstand. Now, in my youth, I did a handstand here while I was walking on the floor in my hands. Everybody would yell, "Logs are exponents." Okay, there are some things that happen with age, and one of them is I can't walk all the way across on my hands, but I can still stand on my hands. So I can stand on my hands whilst you yell, "Logs are what?" Exponents.
Right, so there has to be a lot of buy-in here,
Right.
Even if you're a
Yes, he
freshman,
should do it as
you're
well.
totally confused.
Except his feet would hit the floor.
And if you had your special ed thing, you have no idea what we're talking about. Regardless, there has to be buy-in. You have to like
Right.
yell at
Yeah,
what we
yeah.
need, okay?
All right,
Right.
you ready? So,
I'm ready.
So I'm going to cheat a little bit. My feet are going to go against the board, but we're all going to yell. So because I'm going to talk while I'm on my hands too, right? Pretty impressive. All right, you ready? What are we going to say? Logs are exponents. Very good, very good.
All right. Yeah. Now,
Okay.
by the way, I always have to give this like extra disclaimer. When I first learned that she did this, I was like, wait, what do you do? And why do you do? Why do you do it? Like, is it really
I said
just?
because it's fun, and Mr. Chase said, but
Like, what's the-
logically, I don't understand.
I don't understand the connection. And she was like, there isn't one. It's just like to help him remember. And I'm like, so I was like, all right, we need to like lay some meaning on top of this to make sure that like there's actually like a reason, at least ostensibly, there's like a reason for doing it.
And there is, I did have a reason.
Yeah, it was for fun, right? But I was like, okay, maybe we can redeem this because the relationship between the exponential and the log function is what? Inverted. And what did she do with her body? Inverted. She inverted it, right? Right? Okay, so.
Right? I mean, he's such a nerd. Love him though. Love him though. So yes.
Give it up for Miss Sketch, everyone.
Now, just wait. There will come a time when you have to my class where I'll teach you what cartwheels mean. Thank you. Thank you very
Do I
much.
know what cartwheels mean? I don't know.
Not yet, not yet.
Mr. Chase, you have a demonstration on cartwheels.
I would, but we have to solve this problem. All right. So anyone have an insight? The lightning strike since Miss Dex came in? Well, actually, no. Well, I mean, at some point we might be lost. Don't let that episode influence you too much. Okay. E to the negative x makes me want to do something at least. I don't know about you. What's e to the negative x? I would, but we have to finish this problem. Okay. So e to the x minus 5 times, how can we rewrite e to the x? E to the negative x? 1 over e to the x would be one way to rewrite that at least. Is this striking you yet? Is there anything you see? Look at the structure of this equation. Don't think about how scary it looks or something. Look at what pieces of this maybe remind you of something or look familiar. I mean, the structure of this makes me think of the equation like, I don't know, w minus 5 times 1 over w equals 4. The reason I'm saying that is because I think you know how to solve that equation, right? So does that suggest a method here? What would your next move be? What would your next move be if you were solving the w equation? What would your next move be if you were solving the w? What would you do with the w equation? My thought would be, I see fractions, I do not like fractions. Right? Same? Good. So what would you do? Kira? Or others? What would you do if you had that thought? I see fractions, I do not like fractions. How would you get rid of them? By what? Yeah, I might multiply this by w. Just toward that end, right? So that I would get, what would I get? W squared minus 5 equals 4w. And then I'd be like, oh, now I know what to do. I took algebra 1, I think I know what to do. All right, so let's do the same move here. What's the move here? I multiply by e to the x, and that gives me a very similar, again, we're like thinking about this structure over here as we think about this here. So that's e to the x squared minus 5 equals 4 times e to the x. Yes? Then what would you do? Having had this in your mind? Cassie, sorry. Yeah. Move it over and factor with the e to the x in there and everything. Whew. Pretend it's w and factor it. Is that what you were going to say, Brent? Yeah, I mean, that's what I would do here too, wouldn't it be? Yeah, so someone has a factorization for me. Maybe it factors nicely. If it doesn't, that's okay too. We could use the quadratic formula.
It does, right?
But it does? Does it? I don't know.
It does.
Let's just go and fake. Let's see.
Minus 5.
Yeah, how about a 5 and a 1? Minus 5 plus 1. Okay, great. So I think I get e to the x equals 5. And e to the x equals negative 1. So x equals, yeah, ln 5. Without a calculator, we'll just leave it that way. ln 5, it's like 1 point something, yeah, right? And over here we have x equals ln negative 1. Yeah? Wait.
But like, ln negative 1, like, since, like,
That's not a thing.
It can't exist. Negative 1 can't be, like, non-exist or,
All right, so yeah, I think we need to eliminate this solution. It's certainly true. There are two ways you could kind of come to this reason here that this is not a real. Doesn't provide a real solution for us. You might think, hey, isn't the domain of the log function only positive numbers? So we can't take the log of negative 1 in high school at least. The other way you could come at this, could you figure this out without having even written this down back here at this step here, e to the x equals -1? Could you have made that conclusion? I think you could have, because you could think instead of talking about the domain of the natural log function, you could think about the range of e to the x. Can e to the x output -1? Yeah, I think not, right? Okay, so right away you wouldn't have to go to the last, and you could just right away make that conclusion. So ln5 is the only solution. Let's do another one that's similar, just in practice.
Oh, I wonder what's the first step. 957.
That was Miss Getz's toes right there. By the way, right there. They erased the board. By the way, I apologize for having 't's and z's in the same equation. That's my bad.
Can I just replace the z's with x's?
Those are
Some of you are already like wishful thinking already made it to next. Whatever, do whatever you want. Oh, I forgot to do the first step for you. I'm sorry. I'm a giver. Okay. Don't say I never did anything for you. That's what I meant. It's all good. What are you finding that you need to do and break out? Yeah, you need maybe the quadratic formula. So that's okay. I mean, there's no quadratic that we can't handle. Poultry guys.
Let's see if I'm right. Okay, I will say mine is better. Rooster, like a rooster.
A booster. Okay.
It works. That's
All right, so you multiplied through by 2 to the z. Am I right? Yeah? And then you needed the quadratic formula. What did you get here? 2 to the z equals negative b plus or minus the square root of b squared minus 4ac plus, I guess, there, all over 2. Okay? Is that good? And then you maybe simplified that. You got what? 5 plus or minus root 26. Okay? And then you said z is equal to log base 2 of this is 104, which is 26 times 4 underneath the radical. Pull the 4 out, it becomes a 2, cancel the 2. You can fill in the gaps. Can you? Here, I'll do it off the side here. 10 plus or minus root 104 over 2 equals 10 plus or minus. Sorry. I just skipped the things I thought you might have done before in your life. Okay. All right. So, yeah. So we do need to stop and apply the same scrutiny we had on the last problem to this problem. Can we take the log of 5 minus root 26? Daniel says no. Why? Yeah, I don't have a calculator, but I do know that the square root of 26 is bigger than 5. So I think we're just going to keep the positive one, throw away the negative one, put a box around it, call it a day. Okay? Yeah. So A is 1, B is negative 10, and C is negative 1. Yeah? Yeah. I know. Go ahead and try, at least think about how you might start this problem here. We now have an equation with a log in it. Let's throw some equations at you that have logs in them. Doesn't that sound like fun? So, like I said, we don't need to finish it. What's your first step? I mean, give me something to do here, whatever it might be, Cassie. Yeah, we have this like power rule that we're just dying to use, right? And then divide by 2. Did anyone have another first step before I continue finishing this problem here? Does anyone have another first step? Or no? Are we good? I mean, that's fine. Yeah. Okay, so how would we do that?
Well, so it's a common log, so it's actually 10.
Okay.
Remove the base, and then see what the exponents is like 10 squared equals c squared.
Good. All right, so let's finish these off. By the way, regardless of where you are in life, you either need to do that at the beginning, like Crystal just did, or you need to do it here. I mean, one place or another, you're going to have to turn a log into an exponent here. So, same thing here. What do we have? 10t equals 10 to the 1, or how about just 10? Okay. Or maybe you just know that the common log of something equals 1 implies that that something must be 10. But whatever. Okay, great. So over here, I just want to apply both methods to see where we are in life. We get t squared equals 100, so that t is equal to plus or minus 10. Now have the conversation, if you will. What's going on here? Which one's right? Is 10 seems to be a solution. What about negative 10, though? Does that work? Go back in the original equation and check it. I think it does work, doesn't it? So I like this. I think we have two solutions. This is losing it. Where did we lose the solution, though? I mean, it seems like we did good algebra. Where did we lose the solution and why? Yeah, in this very first step, we made the assumption that what assumption led to the loss of a solution? Think back to our warm-up today. Didn't you, as you move from here to here, assume that t is positive? Because that property doesn't hold if t isn't positive. So you basically said, without maybe saying it, you said, well, let's assume t is positive. Well, maybe t isn't positive. In fact, could be negative, right? We have a solution that's negative. So just be careful. You're welcome to do it this way. Just be at the end and be careful and be like, oh yeah, I also mean negative. I don't know. Somehow get the right answers, please. Like, I don't know how, but like get the right answer somehow. You might just want to be careful and do it the other way over on the right side. I don't mean this one to be too much different. Give this one a try here. Just see if you learned that your lesson. Yeah. Yeah, I mean, in the end, right, t equals plus or minus 10.
Yeah, I mean, when you convert it. Yeah.
Oh, yeah, I like that. Third way. I like that too. All right, did you get the last one, the spot one here? Oh, let me do the first step for you. I'm always looking out for you. There you go. That didn't help you, then I don't know.
That was the fun part.
That was the fun part. Continue.
Fun for the little kiddies.
I don't mean to rob your joy, but didn't think you'd get that first step. Didn't want to get any stuff. How's it going out there? Good. I would just solve x to the 6. All right, here we go. So what'd you get? X to the 6. What does ln mean again? I forget. Oh, that's right. Log base e. Okay. So x to the 6 equals e to the 12th. That means that x equals, I'm taking like a 6th root, I guess, or something. Whatever. Or the 1/6 power. So I get e squared. I think I heard a lot of people say. You like that? Oh wait, yeah, if we learned anything from above, we realized that we don't want to lose the other solution. We actually have two solutions, right? Anytime you take an even root, people over there, you paying attention?
I am.
Plus or minus e squared, please. Okay? Okay, good. Who else didn't have e squared? Didn't have plus or minus. Make sure you have a plus or minus. Okay? Just say yes, sir. Okay, here we go. Let's try another one. Again, I'm just like trying to have even like an inroad on this. Like where do I even, how do I even get started? Give me something helpful, anything that at all. Something helpful, anything? Yeah, combine the logs on the left side, I hear someone say. So how do we do that? That's the natural log of What's the rule? We proved it yesterday, didn't we? So what is it? The sum of two logs is the sum of the products of their arguments, right? So on the left side, I think we can rewrite. You can rewrite it that way. I think that's okay with me. And on the right side, did you do anything there, or we like just 2 elements? Huh? Yeah, it's ln of x squared. Now the only thing you might be thinking, you're like a little gun shy at this point. You're like, I don't know. I don't know anymore. You keep making me feel really cautious about this. You may do that. The only caution you should have in your mind is that you may have just introduced new solutions, right? By doing that, you need to kind of think about, as you're doing algebra, you need to think about what things you're doing that might have introduced new solutions, or which things might have been, like, killed your solution somehow. And you got rid of solutions, right? Good. And then those were the big moves, right? And then, so we have what? 3x minus 2. Using that 1-to-1 property for logs equals x squared. And then we have like an algebra 1 equation. It's messy, but we can solve this. What do we need to do? Multiply it out. You know, let's do this. Here we go. Oh, does that factor nicely? It does? Isn't that convenient? Wow. What do we need? A minus 4 and a minus, oh, both minus, of course, yeah. So what do we get? X equals a half or 2? Okay. And then we already kind of even had this caution in our mind. Let's just go back and make sure that they work here too. It's completely possible at this stage that both don't work, or both do work, or one works and one doesn't. So I hear someone saying one of them doesn't work. Which one doesn't work? 1/2 doesn't work. Both of them are cool here. 2 is cool everywhere. I think 1/2 makes both of these guys undefined though. Yeah. So x equals 2 though is definitely cool in both equations. I guess that's where we'll stop today. And just remind me one more time, what are logs? I forget. Oh yeah, that's right, exponents.